Okay, continuing with the short answer question. Question number 7. An object is placed far away from all objects that can exert force on it. A frame of reference is constructed by taking the origin and axes fixed in this object. Will the frame be necessary inertial? Answer is yes, if net force is 0. Net force 0 है, so either it will be at rest or moving with the uniform velocity. Then it can be inertial frame. Question number next 8. Diagram shows the light spring balance connected to two blocks of mass 20 kg each. The graduations in the balance measure the tension in the spring. What is the reading of the balance? So this side 20, this side 20. So it will be at rest and force will be 20 kgf. Answer is 20 kgf. And because tension will be 20 kgf, system is at rest. ये 20 kgf है नीचे. It is not moving. This also will be 20 kgf. Okay. Will the reading change if the balance is heavy? Say 2 kg. No, because it is in horizontal condition. No effect of weight will take place. Third one is what will happen if the spring is light, but the blocks have unequal masses. The spring balance will move in certain direction. So whatever the tension comes, that will be reading depending upon the masses. The weight indicated will be equal to the tension. The reading will be according to the tension. The acceleration of the particle is 0 as measured from the inertial frame of reference. Can we conclude that no force acts on the particle? The answer is no, because there may be many forces acting on the particle. But net force will be 0. Then only acceleration will be 0. Answer is, next question is, suppose you are running fast in the field. When you suddenly find a snake in front of you, you stop quickly. Which force is responsible for your deceleration? Answer is friction force. We apply the force on the ground in forward direction. Friction is in backward direction. It decelerates us, retards us. Okay. Question number 11. If you jump barefooted on a hard surface, your legs get injured, but they are not injured if you jump on the soft surface like sand or pillow. Explain. It is due to the rate of change of momentum. More force in first case due to the fast change of linear momentum, and vice versa in the second case. Because first case में okay, force is change of momentum upon time. Time is less in the first case, therefore more force. Next question. According to Newton's third law, each team pulls opposite team with the equal force in the tug of war. Why then one team wins, another team loses? Okay. Tension applied is more equal on the string, but the person or the team which is pushing the ground harder, producing the more friction, will win. That will win. All right. That more friction will pull that string complete. If friction is more than the tension, then it will start moving this side. 13th, a spy jumps from the aeroplane with his parachute. The spy accelerates downward for some time. When the parachute opens, the acceleration is suddenly checked, and the spy slowly falls on the ground. Explain the action of parachute in checking the acceleration. So initially there's free fall. Later on, when the parachute opens, the more area, therefore more air resistance in opposite direction, which reduces the downward acceleration. More area बढ़ जाता है, air resistance ज़्यादा हो जाता है for same weight. Okay, consider the book lying on the table. The weight of the book and the normal force by the table on the book are equal in magnitude and opposite in the direction. Is this an example of Newton's third law? Answer is no. It is not. Book applies the same force on the earth. ये W लगा रहे हैं, तो अर्थ के ऊपर बुक भी सेम लगा रहे हैं. तो that's the Newton's third law, not of the table. तो वेट का रिएक्शन वेट ही आएगा थर्ड लॉ में. जैसा फोर्स है, वेट है ग्रेविटेशन फोर्स, तो वही ग्रेविटेशन फोर्स का ही जो पेयर बनेगा, है ना. एग्जांपल सपोज फ्रीली फॉलिंग है. if the person, if the table is falling freely falling है, तो weight is still there but no reaction, you know. In case of freely falling, still the action reaction pair of the earth and book remains. Newton's third law is there for the book and earth. And table, no reaction comes now. All right. Fifteenth, two blocks of unequal masses are tied by the spring. The blocks are pulled, stretching the spring slightly, and system is released on the frictionless horizontal platform. Are the forces due to the spring on the two blocks equal and opposite? Yes, because F is equal to Kx. Change of length of the spring is same, force will be same. Okay. If yes, it is example of Newton's third law. Answer is no, because the forces are acting. These forces are not due to each other. These forces are due to the spring. It is three body system actually, not the two bodies. देखो, forces on each block is same. Okay, this already explained. Second case, no, it is not Newton's law. These two forces are not due to each other. They are due to the spring. Direct each other force नहीं लगा रहे हो. Action reaction direct forces का नहीं है. तो it is not Newton's third law. When train starts, the head of the standing passenger seems to push backward. Analyze the situation for the ground frame. Does it really go backward? Answer is no. It tends to remain there, but his body goes forward. Legs goes forward, the body goes forward. Coming back to the train frame, how do you explain the backward movement of the head on the basis of the Newton's law? It is from the first law. Head tends to remain there because no force on the head, whereas lower part of the body is pulled forward by the train because of the friction or because of the some other forces. All right. The answer जो मैंने discuss किया, with respect to the ground frame, it remains at rest. Legs goes forward. Legs and lower part of the body goes forward. From Newton's third law, no force on the head. It tends to remain there, and lower part of the body goes forward along with the train. All right. First law, दोनों cases की explanation. Plumb bob is hung from the ceiling of the train compartment. If the train moves with the acceleration A along the straight horizontal track, the The string supporting the bob makes an angle this much with the normal to the ceiling. Suppose the train moves on an inclined straight track with the uniform velocity. If the angle of incline is tan inverse A by G, the string again makes the same angle with the normal to the ceiling. Can a person sitting inside the compartment tell by looking at the plumb line whether the train is accelerated on the horizontal straight track or it goes on incline? If yes, how? If no, suggest the method to do so. So it is difficult for him to find out whether train is accelerating really or going on the inclined plane with the constant speed, because in both the cases it will be inclined with the normal. But in first case tension will be more. Okay, spring balance agar laga to you can say here pseudo force backward mg. ये दोनों force का vector sum will be tension. Here it will remain vertical because no acceleration, uniform velocity, है ना? तो इसमें no force on inclined direction except vertical. So it will remain vertical. So tension will be equal to mg. Mg will be equal to T. Tension less here and more here. Okay, that's all.